Hello everyone, welcome to A plus PI. This channel is all about complex numbers, and in this video we're going to be solving a very nice quartic equation. I call it very nice because we only have z to the fourth power, so that should be fairly simple, right? Now if you try to solve this equation with real methods, then you'll get something like this, and then you can take the fourth root of both sides, but then you're going to get stuck because we cannot find the fourth root of a negative number in the real world. That's why we do need the complex world, and that's why we need A plus PI. What is A plus PI? It's the name of this channel. So hopefully you don't forget that, right? So I'll be presenting two methods, and I'm trying to rest my voice these days because I have sore throat. Hopefully I'm not gonna lose my voice, but if I do, then I will probably have to make some videos, no talking, just music. So don't hate me for that. Keep watching. Keep up the good work, okay? So, first method, we're gonna go ahead and factor this expression because we can. Write the 81 as 3 to the fourth power, and then let's go ahead and try to factor this. To be able to factor sum of fourth powers, you can think about it as follows. A to the fourth plus b to the fourth can be written as a squared plus b squared squared. That gives us everything on the left plus 2a squared b squared. So if I subtract it, then I'm good to go. And if you think about 2 as a perfect square in the irrational world, it is, right? It's root 2 squared. Then you can factor it by using difference of two squares. That's the secret behind Sophie Germain, right? Remember that identity? It's a beautiful identity. Anyway, so let's go ahead and factor this then using the formula. Z squared plus a 3 squared, and now square that. Subtract 2z squared times 3 squared. This is a perfect square, and this is a 2 times 9. Another perfect square. And we know that this equals what? 0, right? Great. It's nice because when I set the whole thing equal to 0, then I get a really nice equation. By the way, this equation can be solved in different ways. One method would be, you can replace z squared with something. Let's say you can say, okay, z squared equals w plus 9 squared minus 18w equals 0. This will become quadratic. You solve for w, you get two values, and then set w equal to z squared. In other words, take the square roots, and then you'll get all the four solutions because this is quartic. Or you can do it this way. I think this method is more intuitive, in my opinion. Just put these things on different sides, and then take the square roots considering the plus minus signs. If you take the square root, this is going to be z squared plus 9. And if you square root this, remember that came from 3 root 2 squared. It's going to be 3 root 2 with a plus minus sign and then a z. Now put everything on the same side. You'll get two quadratic equations. And that'll give you a sum or total of 4 solutions, right? Sum and total sometimes mean the same, sometimes they don't. How do you solve it? Let's take a look at each one. Actually, if I solve one, the other one is going to be very similar. Would you just do that one, or we can do both? Okay, fine. Let's take a look at this one first. This one will have z equals negative b plus minus the square root of b squared, which is 18, minus 4ac, which is 36. And that'll be, the next equation is going to be very similar to this. Square root of 18, that's going to give us plus minus 3 root 2i, because that's not real, divided by 2. And obviously we can separate this, right? Let's go ahead and look at one of the roots. For example, this one. Okay. Now in this equation, we can definitely take out a 3 and write it this way. And why would you take out a 3? Because 3 is the modulus. Make sense? Okay. I hope it does. And inside you have a complex number whose modulus is 1. Did I say modulus? Yes, I'm sorry. It is the modulus, and yes, inside the parentheses it's going to be modulus 1 again, like cosine theta plus I sine theta, and from there you can find the value of theta, right? Obviously, but you can leave it at that. This is perfectly fine. If you look at the other equation, this one. Similarly, we're going to get negative b is going to be plus this time, but everything else is going to be the same. So it's going to look like this. And then you can definitely separate this into this, right? And it's going to start with a plus sign. So the plus sign means we're in the first or fourth quadrant, right? Because of the plus minus signs. And then again, we have a modulus of 1 inside the parentheses, right? So 4 solutions in total, and notice that they have something in common. And we'll see that with the second method. Okay, let's go ahead and take a look, because the second method is going to reveal more information. Now, with the second method, we're going to kind of take the roots, but in the complex word. Let's go ahead and subtract 81. That gives us negative 81. And now I want to write negative 81 in the complex word, in polar form. The modulus is going to be 81, but our number is going to be here. So we could consider that with an argument of pi, or we can add, you know, the multiples of 2 pi, right? It's going to be 81 times e to the power I times pi. Well, let's just go ahead and add 2 pi k, where k is an integer. Okay, so far so good. All right, once we get the z to the fourth, we can go ahead and fourth root both sides. Z is going to be, now this is modulus, so it's a real fourth root, which is 3. And then this one is just going to be I. And then I'm going to divide everything by 4 inside the parentheses, pi over 4. And then this is going to be pi k over 2. So you can think of it this way. Add multiples of pi over 2 to pi over 4 every time. So they're separated by pi over 2 because 2 pi divided into 4 pieces. The fourth roots are distributed equally on the unit circle. Make sense? Okay. Unit circle, of course, I'm excluding the 3, just considering 1 as the modulus. All right, great. Let's go ahead and take a look at some particular values. For example, if k is 0, z is going to be 3 times e to the power I pi over 4. As you know, I pi over 4 is cosine pi over 4 is root 2 over 2, and sine pi over 4 is the same. So you're going to get this number. Notice that when we solved it with the second case, we did get it with a plus sign. This is one of the solutions. If k is equal to 1, then you're going to get z equals 3 times. You're going to add pi over 2 to this. That's going to make it 3 pi over 4. So we can write it as 3i pi over 4. And then from here, the modulus is 3 pi over 4. So it's going to be, notice that pi over 4, pi over 2, 3 pi over, it's going to be in the second quadrant. Cosine is going to be negative, but sine is going to be positive. And by going in this manner, you can basically find all the solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.